When we covered databases in CIS 133Y, we used a popular relational database called Microsoft SQL Server. Now, a relational database refers to a type of database of which there are many examples, where data is organized into tables, and a table is basically a grid that has rows for each separate instance. So for example, if I was doing a system about music videos and I wanted to have a table of information about music videos, each row in the table would be a different video. So each row is a different video and each column is a single piece of information about each video in each row. Then typically if you're using a relational database, you use something called SQL, which is structured query language, in order to access information in the table. So you can store new rows, you can update values in existing rows, you can select a sequence of rows or a subset of the rows to return and look at, and so on. But you do that by sending SQL commands to the database, and the database either changes the data or returns a result set. And you can look at the result set and do something with it. What we're going to be doing in 233Y is similar, but a little bit different. In the last, I would say, 20 or 30 years, different ways of organizing data have become popular for a variety of reasons, which are a little beyond the scope of this course. But one of the ways of organizing data that's different is something called a document database as opposed to a relational database. So once again, in a relational database, you store information in tables. In a document database, you store collections of documents, and then each document is basically looks a lot like in Python a dictionary. So in a dictionary in Python, you have key values, which can be basically whatever property you want them to be. And then the value associated with that key in the dictionary can be pretty much whatever you want it to be as well. So you can have properties in a dictionary that hold values that are other dictionaries or are lists of values, and then the values inside of those lists can be other lists or dictionaries, strings, numbers, and so on. It's all very flexible. You can put almost whatever you want almost anywhere in a dictionary-oriented system. So this makes some parts of development significantly easier compared to a relational database. So in a relational database, if you want to change your data model, if you want to add a column to a table, or you want to add additional tables, you want to link multiple tables together using key relationships and so on, you pretty much have to change all of the data that's already stored in the database. And that is usually pretty heavy lift technically. It requires consensus. You have to look at all your code, and it's pretty significant change. Whereas if you're talking about a document-oriented database, you just change the structure of the dictionaries you're storing in a collection. You can design a database schema which will put some restrictions and error checking on the stuff that you store in a collection, but by default it's all very flexible. Some people find writing SQL queries to be challenging. If you were one of those people, then you're going to enjoy working with a document-oriented database because there's no real query language to speak of. The particular version of a document-oriented database that we're going to be using in this class is called MongoDB. It's one of the more popular so-called NoSQL databases. So NoSQL database is a whole collection of different ways of storing data that are non-relational and generally don't feature SQL, though some of them do. NoSQL is basically marketing speak for anything that isn't a relational database, and MongoDB is one of the more popular NoSQL databases available. In addition, MongoDB is also cloud deployed so that you can put your database in the cloud and connect to it from an application running on any machine on the internet. And that's also a useful thing to know about as you go forward doing development, where more and more infrastructure is being deployed to the cloud and less is being deployed in a single instance that's running on somebody's desktop or somewhere. So the specific details of working with MongoDB, we're going to be covering that this week and next week in Lab 3 Progress Check and Lab 3 Final. And by the time we finish, we will have a complete back end for our item list manager systems.